Let's talk a little trig today. We're going to find the tangent of an angle. We'll call that angle alpha, given that alpha is in quadrant 2, and also given that the sine of alpha is 3/5. So the first thing I like to do is I like to draw a reference triangle in that quadrant, quadrant 2. And all reference triangles drop down towards the x-axis. And I'm going to put in 3/5 for the two lengths of sine, which are y over r, the radius. And then if you need to use the Pythagorean theorem, you can. Solving for x, I get 4, or you know your Pythagorean triple, 3, 4, and 5. So x should be 4, but actually, since we're in the second quadrant, going to the left, x is -4. So we're in that negative direction. So the tangent of that angle should then be 3 over -4, because tangent is going to be y over x. We can see this illustrated when we look at a sine curve. So I'm going to go ahead and draw a sine curve just restricted from 0 to 2 pi. And notice when I draw my curve and I think about y equals 3/5, you can see that that red line, 3/5, y equals 3/5, intersects the sine curve in two places. However, it only intersects the sine curve in one place if I'm only looking in quadrant 2, which is the value between pi over 2 and pi. So down below, I'm going to also draw a tangent curve with the same values from 0 to 2 pi. So that'll give me 2 periods of tangent, and you can see my asymptotes going in right now. So there's my tangent, and right below the place where the red line intersected with the sine curve, right below there, you can see that the tangent value is going to give me that -3/4. And so there's only one place that that happens at the same time. So when this unknown alpha gives me a sine ratio of 3/5, then the tangent ratio at that same location is going to be -3/4. And that's doing all of that without ever finding what the alpha angle actually is. Thanks a lot.